Okay, we have here yet another bungee jumper. So the first thing we check is the KE. At the top and at the bottom, the bungee jumper is at rest, so we expect the KE to be 0 at the top and at the bottom. At the middle, of course, it cannot be 0 because the bungee jumping cannot be stationary, right? When it's at the middle of the bungee jump. So with that, we can eliminate B and D as well. Next thing we can check is the total energy should be conserved. So if we sum up the GPE, the elastic potential energy, and KE at each position, it should give us the same number. So we have a total of 120 joules at the top, then we better have 120 joules when it's at the middle and also when it's at the bottom. So if you do this check, we can eliminate option C because it shows that at the middle, suddenly the bungee jumper has a total energy of 150 joules. Where did the extra 30 joules come from? That's not possible because energy has got to be conserved. So for this question, we are lucky. The options are given such that we don't have to look further. We can straight away choose A to be the answer. In a more complicated question, maybe we also have to check the GPE. What we look out for in the GPE is going from top to middle and going from middle to bottom. The decrease in GPE should be the same. So if we lose 60 joules of GPE going from top to middle, then we should lose another 60 joules going from middle to the bottom. It's because going from here to here is the same vertical distance as going from here to here. Same vertical distance, same decrease in height should be the same decrease in GPE. Alright, so this is one thing that we may have to check in a more difficult question. In even more difficult questions, we may have to look at EP as well, elastic potential energy. And what we should be looking out for is that going from top to the middle, if the increase in elastic potential energy is 10 joules, like in this case, then we expect the increase in the elastic potential energy going from the middle to the bottom to be larger than 10 joules. This is because the elastic potential energy does not increase linearly with extension. It increases quadratically. So going from top to middle and going from middle to bottom is the same increase in the extension, but it should not result in the same increase in EPE. It should result in a larger increase in EPE. So for example, we know that this option cannot be correct because when we stretch it by a certain amount, the EP increases by 30 joules. Then when we increase it further by the same amount, if we stretch it further by the same amount, the increase in EP has got to be more than 30 joules. It cannot be the same because of the quadratic nature. Alright, in fact, we expect this number to be at least 120 joules. Alright, similarly, this one cannot be correct. We expect this number here to be at least 240 joules. Okay, this one looks okay. Of course, that's the answer.